Hello friends, welcome to my channel Academic Made Easy PC. If you have not subscribed my channel, subscribe it and also click the bell icon. Next topic that we will be learning is operation on matrices. So here we will be learning addition and multiplication of matrices. So first we will be learning about addition of matrices. Addition of matrices. If A is equal to Aij and B is equal to Bij are of same order, that is M by N, then the sum of two matrices A and B is defined as matrix C is equal to Cij M by N matrix, where Cij is equal to Aij plus Bij for all possible values of I and j. So for addition of matrices, we have to have two matrices and those two matrices should have same order. Then we can have addition of that matrix. So now let's see an example. Example, A is equal to 1, 2, 4, 9, 7, 8, which is 2 by 2 matrix. B is equal to 5, 3, 6, 1, 7, 2. This is also 2 by 3 matrix. So this order of these two matrix are same, so I can perform addition in these two matrix. So now I have to write these two elements as it is. So my A is 1, 2, 4, 9, 7, 8. This is my matrix A plus, so what is this matrix B? 5, 3, 6, 1, 7, 2. This is my matrix B. So now how will I do addition is that I will be adding the corresponding elements. I have already taught you what is corresponding elements, isn't it? So I will be adding these corresponding elements. So here I have 1 and 5. So I will add those two. 1 plus 5. So this will be my A11. So next I will have 2 plus 3. So next I have 4 and 6. So 4 plus 6. So next I have 9 plus 1 and 7 plus 7, 8 plus 2. So now I will be adding all these elements. So what is my first one? That is 1 plus 5 is 6. 2 plus 3 is 5. 4 plus 6 is 10. 9 plus 1 is 10. 7 plus 7 is 14. 8 plus 2 is 10. So this is my required matrix, that is Aij plus Bij is equal to Cij. So I'm saying here, let this be matrix C. So this one I have got it. So the addition will be done just like this. This is very simple. So we have to know how to add. That is, we will be adding only the corresponding elements, not all together. Now let's see a special case. A is equal to 1, 2, 5, 7, 9, 2 and B is equal to 1, 2, 3, 4, 5, 6. This is of the order 2 by 3 and this is of the order 3 by 2. This has 2 rows and 3 columns. This has 3 rows and 2 columns. If we add the corresponding element also, see 1 plus 1, 2 plus 2, 5 plus what will you add? You can't add with anything, no. So therefore, the order of this matrix is not defined. We cannot add these two matrices because the orders of the given two matrices is different. Now let's learn about properties of matrix addition. So how can we add, and the properties, different types of properties we have learned in lower classes, isn't it? The same thing, can we apply it for matrix also? There will be a question, right? So to answer all these questions now, let's learn the properties of addition. So first property is commutative law. Addition is always commutative, isn't it? So if A is equal to Aij of some order, B is equal to Bij of the same order. It should be same order, isn't it? In the previous topic I taught you, are matrices of the same order. See, same order. Underline this for addition. Then A plus B is equal to B plus A. This is the condition. So commutative law is true for matrix addition. Next property is associative law. For any three matrices, A is equal to Aij, B is equal to Bij, and C is equal to Cij of same order. See, everywhere it is of same order. No? Say M by N, then A plus B plus C is equal to A plus B plus C. So this is true for associative law for addition of matrices. Existence of additive identity. So here let A is equal to Aij, B and M by N matrix, and OB, see, always this O represents the zero matrix. OB and M by N zero matrix, then matrix A plus 0 matrix is equal to 0 matrix plus A matrix is equal to matrix A itself. So this is the additive identity. So in lower classes we have learned some number plus 0 is equal to the same number, isn't it? Here also same. A matrix with a 0 matrix is equal to the same matrix itself. Existence of additive inverse. So in the normal properties itself we have learned some number plus negative of that number is equal to 0. The same here, let A is equal to Aij M by N matrix. Then we have another matrix A minus A is equal to minus Aij of the same order, such that A plus minus A is equal to minus A plus A is equal to 0 matrix. Let's learn about multiplication of matrix. So we have two types in which we can do multiplication. One is with square matrix and the other with the number of columns and number of rows are not equal. We will be learning that. What is a square matrix? Number of columns is equal to number of rows, isn't it? So we will be learning this, as well as when M is not equal to N also we will be learning. First, I have splitted these two into two cases, that is case 1 and case 2. So now I have taken in case 1 the square matrix alone, and this in case 2 when number of rows is not equal to number of rows I have taken. So now let's see case 1 first. So in case 1 we will be learning only the multiplication of square matrices. Okay, so now let me teach you how to perform multiplication in matrix. So this multiplication of square matrix will be done only when it is a square matrix, when both also is a square matrix. So here when A matrix is of some order M by N and B also with some M by N, then the order of matrix also will be M by N only. So when this order of two matrix is equal, then we get the same order of matrix. So now let's see with an example. So I have given the example A is equal to 1, 2, 3, 4 and B is equal to 1, 3, 5, 4. So now let me teach you how to do multiplication. So it will be A into B is equal to 1, 2, 3, 4 into 1, 5, 3, 4. So this is what we have to multiply. So in addition, directly we added the corresponding elements, isn't it? But here for addition, you should not multiply the corresponding elements. Instead, what you have to do is that first we will be taking this row. So we need not to worry with this matrix. We will be taking only this matrix. So I have 1 plus 2. So how many columns do I have here? 2 columns. Here also 2 columns, isn't it? So I will write once more. So 1 plus 2. I will write this as it is, 1 plus 2 and 1 plus 2. And here I will go to the next row, which is 3 and 4. So I will write 3 plus 4 and once more I will write 3 plus 4. Till here, is that okay? So now what I have to do to multiply? You all may ask, it's multiplication, why have you added? It's not addition. I have to multiply with this matrix. So what I have to do is that I should go in 7. So 7 means like, so 1, 2 with this. I will be multiplying with this and with this column. So be clear. See, first row of the first matrix, I will be multiplying with the first row first for A11. So next I will be going with first row with second column. So I will be doing with this. Just see here, first element with first element. So 1 into 1, then second element into this second element, so 3. Next I will have like 1 into 5. So this till here my A11 is over. This fully is A11. So I will move on to A12. So 1 into 5. Into 5. Next I will move on to 2 into 4, the second element with second element into 4. See, I have completed my first row. How much ever columns you have to do so much. If I have 3 columns over here, thrice I will write the same. Okay, so this first A11 you will multiply with first column. Then A12 you will multiply with the second column. So now if I go to the second row, the second row also same. Second row first time you will go with first column. So 3 into 1, 4 into 3. So next you will go for second column. No, so that time you will multiply with second column. So 3 into 5 plus 4 into 4. So this is what your matrix. So now you can multiply and then add to get the answer. So 1 plus 6. Next here it is 3 plus 12. 5 plus 8. 15 plus 16. So therefore in the next step you will have 1 plus 6 is 7. 5 plus 8 is 13. 3 plus 12 is 15, 21. This is the required matrix. Now let's learn case 2, that is the multiplication of non-square matrices, that is when m is not equal to n. So now let's see an example, then it will be clear for us. So everything is same for square matrix multiplication as well as this normal matrix multiplication. Only slight difference will be there. The order of the matrices will change. Only that is the difference. So now let's move on to the example. So here I have given the example A is equal to 1, 7, 2, 3, 4, 5, which is 3 by 2 matrix, and B matrix is equal to 6, 1, 3, 1, 2, 8. This is of the order 2 by 3 matrix. So now let me teach you all how to multiply. So now we have to multiply these two. No, so what I will do is that A into B is equal to, so now I will multiply the matrix A and B. So I will have 1, 7, 2, 3, 4, 5. So this is matrix A and my matrix B is 6, 1, 3, 1, 2, 8. This is my matrix B. So now first I have to find the order of matrix, so in order to multiply it. So how will I find the order of matrix? Directly by seeing here? No. For this, the order of matrix, finding the order of matrix is slightly different. So I'll teach you now. So to find the order of matrix, so you have to write the order of both the matrix. First is 3 by 2. So if you are taking A dot B, that is A matrix A into matrix B, then you have to take the order of matrix A first, then matrix of B second. So now I have written both these order, isn't it? So I will be cancelling out these two. Next I will be writing only 3 by 3, the remaining. Since here both the numbers are same, isn't it? So I have cancelled these two. This is the method. This is the standard form to find the order of matrix when the order is different. So 3 by 3. So now I will have 3 by 3 matrix in the answer. So now let me teach you how to do that. So as we did for the previous example, no, the same thing we will be doing. Only thing is that I said, you know, how much ever columns we have, so much we have to do. No, so here I have 1, 2, 3. 3 columns I have. So what I will do is that I will write this 1 plus 7 thrice. So how much ever columns I have, if I have 4 columns, I have to write 4 times. That is whatever 1 plus 7. 1 plus 7. We did only twice, no, for the previous example. This time we will be doing for 3 times. Why? Because I have 3 columns over here. I have to check how many columns I have only. So 1 plus 7. Next I will go to the second row, which is 2 plus 3. 2 plus 3. 2 plus 3. Next I will write 4 plus 5. 4 plus 5. 4 plus 5. So now I have to multiply with the matrix B. So I have written the rows now. So next I have moved to the column. So first row with first column, next first row with second column, first row with third column. We will be doing it in such a way. Now let's move on. So 1, the first element with first element, the second element with second element. We have to do like that. So here first element into first element, so it will be 6. Next second element into second element, that is 7. 1. Fine. So next I will move on to the second column. So first element with first element, 1. Second element with second element. Next, this is over now. So next I will move on to the third column. So first element with first element, that is 3. Next second element with second element, that is 8. So now for the first row we have found everything. No, so directly instead of seeing for each and every element, directly we can write what we have written here. So here also it will be 6, 6, 1, 1, 1, 1, 2, 2. So only I have written in a straight line so that I can identify and write easily. So 3, 3, 8, 8. So now it's easy for us to do the calculations, isn't it? So now I will multiply. So 6 ones are 6 plus 7 ones are 7 and 1 plus 14, 3 plus 56, 12 plus 3, 2 plus 6, 6 plus 24, 24 plus 5, 4 plus 10, 12 plus 40. So after adding I will get here 13, 15, 59, 15, 8, 30, 29, 14 and 52. So this is my required 3 by 3 matrix. So that's it. So if it is square matrix, we'll get in the same order. If it is not a square matrix, then we have to find the order and perform the multiplication. There is no much difference. Only thing is that the order is different. That's it. Now we will be learning properties of multiplication of matrices. We already learned the properties of addition of matrices, isn't it? The same thing, even in multiplication, we will be learning those properties. So first one is commutative law. So multiplication of matrices, any two matrices, is not commutative. That is, a commutative law doesn't get satisfied for multiplication of two matrices. So now just I'll give you an example so that it will be easy for you all to understand also, and it is one of the important property also which you may get for 1 mark. For example, consider these two matrices A and B. So now I will do for A into B, then we'll go for B into A. Okay, so first I will go with A into B. So first I will write 1, 2, 3, 4, which is matrix A, and next I will write matrix B, which is 4, 9, 1 and 3. So this is square matrix, so I will get 2 by 2 matrix only. So therefore I will write, since I have already taught you in the previous topics, I am just doing it little fast. So first I will be writing rows. So how many columns do I have? 2 columns, no? So I will write 1 plus 2, 1 plus 2. Then 3 plus 4, 3 plus 4. Always if you write like this, then it will be easy for you to perform the addition or multiplication. So now I have taken this first row. First I will take for first column. So 4 and 2 into 1. So 1 into 9, 2 into 3. So now directly I can write, no? So 4, 1, 9, 3. So if you have any doubt in doing this, mention it in the comment box. I will make one more video with an easy way. So here 1 into 4 is 4, 2 ones are 2, 1 nines are 9, plus 2 threes are 6, 3 fours are 12, plus 4 ones are 4, 3 nines are 27, plus 4 threes are 12. So next I will have, which is equal to 4 plus 2 is 6, 9 plus 6 is 15, 12 plus 4 is 16, 27 plus 12 is 39. So this is the required matrix for A into B. Now I will be doing for B into A. So now what will be my B matrix? It is 4, 9, 1, 3. And my A matrix is 1, 2, 3, 4. Isn't it? So now I will be applying the multiplication. So 4 plus 9, 4 plus 9, 1 plus 3 and 1 plus 3. So now what is the condition? I have to multiply the first row with first column and first row with second column and second row with first column, second row with second column. No. So I will be going for first row and first column. So 1, 3. So here 4 into 2, 9 into 4. So now directly I can write, no? So 1, 3, 2, 4. So now I will 4 plus 27, 8 plus 36, 1 plus 9, 2 plus 12. So now I will add to get my matrix. So here 4 plus 27 is 31, 36 plus 8 is 44, 1 plus 9 is 10, 2 plus 12 is 14. So therefore this is the required matrix for B into A. So what was the answer for A into B? It was 6, 15, 16, 39. And what is the answer for B into A? 31, 44, 10 and 14. So A into B is 6, 15, 16 and 39. And B into A is 31, 44, 10 and 14. What is the condition for equal matrices? That is the corresponding elements or entries should be equal. So is any corresponding elements equal? No, therefore they both are not equal. So we have proved that A into B is not equal to B into A. So therefore commutative law does not get satisfied for multiplication of matrices. Second is associative law. So A into B into C is equal to A into B into C. So the associative law is true for multiplication of matrices. Next, we'll move on to distributive law. So here it is A into B plus C is equal to AB plus AC. Next, A plus B into C is equal to AC plus BC. So therefore, distributive law is also true for multiplication of matrices. Next, we learn for existence of multiplicative identity. So for any square matrix A, there exists an identity matrix of the same order such that IA is equal to AI is equal to A. So this is identity matrix. Identity matrix means what? 1, 0, 0, 1 if it is 2 by 3. If it is 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is the identity matrix for 3 by 3. No. So therefore the multiplicative identity. So here I into A is equal to A into I is equal to A. The next property is properties of scalar multiplication of matrix. Scalar means what? Any constant or any number, isn't it? So therefore they have given K into A plus B. A and B are some matrices and K is some scalar constant or any number. So this can be multiplied inside. So therefore we will get Ka plus Kb. So if we add like this or multiply and add like this or add and then multiply with the constant, it is same they are saying. And they have given two constants over here. K and L are some constant and A is a given matrix. So multiplying and then adding and then multiplying with a given matrix and multiplying directly with the matrix and adding also is same they are saying. So that's it. The properties of multiplication of matrix is over. Now we will be learning about transpose of a matrix. Transpose is nothing but, so when we have, for example, just take, for example, you have a rod like in this way. Okay, consider this as a rod. In this way, you are interchanging like this. Then it is called transpose. It is just similar to it. If you have something like this, you will change it to this position. If it is in this position, you are changing it in this position. Then it is called transpose. So similarly, in transpose of matrix also, we will be just changing the elements. So if A is equal to Aij of m by n order, interchanging of rows and columns of A is called transpose. That is, when it is in column, we will change it to row. When it is in row, we will change it to column. Okay. So it is represented by A dash or A transpose. This is also read as A transpose only. So A dash or A power T is called a transpose of a given matrix. So when A is equal to Aij of m by n matrix, then A transpose will be just opposite. M by n here it is means then it will be n by m. So that is what given over here. Now consider this example 102970. So this is the matrix A and m by n is 3 by 2. So what will be my A transpose or A dash? It will be Aij. I'm just writing it as Aij of what order? 2 by 3. It should be 2 by 3 matrix. Now, so how will I find my A transpose? Now I'm going to teach you that. So here this is one column, this is one column. First column, second column. Isn't it? So now what is transpose means? Changing my rows into columns or column into row. Always keep it in mind that don't be confusing yourself changing rows into column or column into rows. Always change columns into rows for transpose, because it keeps confusing you if you're changing column into row or row into column. Just change this. I said no, I keep a rod like this, and if you are changing it like this, then it is called transpose. So my rod is just like this, I'm just changing it like this. So it means 1 I have as it is, then 0. Instead of writing here, I will be writing here 0, 2. So this column is changed to row. So now you will be understanding why I drew all these lines. So next column I will go 9, 7, 0. That's it. This is my transpose. Isn't this very easy? Very easy topic this is. So next topic is properties of transpose of a matrix. So this is one of the very important properties that we may get from one word answers. So directly we won't be asked to do this formula. We will be asked to do a sum using this formula, based on this formulas. So be very clear. So A transpose, the whole transpose is equal to A itself. So for example, when we take here itself, so this is A transpose of 2 by 3 matrix. No. So if we take again transpose of transpose, means A transpose, the whole transpose means, so here I will be changing my column to row. So if I change my column to row, 1, 9. Second column 0, 7. Next will be 2, 0. Didn't I get the same number here, the same same matrix here? That only they are saying in the first property. So the next property is with some constant. So constant into matrix, the whole transpose is equal to constant will remain as it is. Only thing is that the matrix will keep changing. So that's what is given here. The next is A plus B, the whole transpose is equal to A transpose plus B transpose. You can just take this transpose inside for addition, and next they have given for multiplication. A into B, the whole transpose is equal to B transpose into A transpose. So this whole transpose is equal to B transpose into A transpose. This is one of the important property. So first let's learn about symmetric matrix. A square matrix A is equal to Aij is said to be symmetric if A dash is equal to A. Symmetric means what? If we cut into half, it is same. No. One thing can be cut into two equal halves. It's just like that. So they are saying that A is equal to A transpose, or A transpose is equal to A. So both the sides should be equal. That is, both sides it should have the same. No, that only they are saying in the symmetric matrix. So here, that is Aij is equal to Aij. If we take transpose also, we have to get the same matrix A for all possible values of I and j. So now I have given the example over here. Example, consider this matrix 1, 2, 3, 2, 5, 8, 3, 8, 9. So now I'm going to take the transpose of A. So what I have said for transpose of A, I will be changing all my columns into rows. So if I have it like this, I will be changing it in this way. So 1, 2, 3. Next is 2, 5, 8. Next is 3, 8, 9. So isn't these two matrix equal? 1, 1, 2, 2, 3, 3, 2, 2, 5, 5, 8, 8, 3, 3, 8, 8, 9, 9. These two are equal, no? So therefore I will say A is equal to A transpose. Therefore it is called symmetric matrix. Next, let's learn about skew symmetric matrix. Skew symmetric matrix, there's a slight change in skew symmetric matrix. Okay, so a square matrix A is equal to Aij is said to be a skew symmetric matrix if A transpose is equal to negative of matrix A, that is Ji is equal to minus of Aij for all possible values of Inj. That is, this is the condition for skew symmetric matrix. Okay, so now let me give you all an example so that you will be very clear. So now I will be changing all my columns into rows. So 0, -1, -9. First column is over, so here first row is over. So next is 1, 5, -6. So next I will go for 9, 6, 1. See here, so 0, 0, 1, -1, 9, -9, -1, +1, 5, 5, 6, -6, 9, -9, +9, -6, +6, 1, 1. See, everything is negative, isn't it? So B transpose is equal to negative of B. Some important notes that had to be made is P is equal to half of A plus A dash is a symmetric if P dash is equal to P. So these notes, no, we will be using it in the exercise. So in exercise I will explain you clearly. You just make a note of all these points so that it will be easy for us to do the sums. Q is equal to half of A minus A transpose is a skew symmetric matrix if minus Q transpose is equal to Q. Is any square matrix can be expressed as a sum of symmetric matrix and a skew symmetric matrix. That is, A is equal to 1 by 2 into A plus A dash, that is A transpose, plus half of A minus A transpose. This is an important note that had to be made so that we will be able to apply this in exercise sums. Then the last topic in this chapter is invertible matrices. So we will be checking that whether this matrix has inverse or not. Okay. If A is a square matrix of order M and if there exists another square matrix B of the same order M such that AB is equal to BA is equal to I. If it is A into B and B into A is equal to I, that is identity matrix, then B is the inverse of matrix A. It is denoted as A to the power -1, that is A inverse. In that case, A is said to be invertible. If it exists, then it is called inverse matrix. Then an important note is AB the whole inverse is equal to B inverse A inverse. This is the important property that we may get for 4 marks or 6 marks too. If you have any doubts, mention it in the comment box.
Like, comment, share and subscribe.